So good morning to all of you. Today, now I am going to discuss one more important in research, which is FPGA. Basically, what is FPGA? FPGA, as the name suggests, Field Programmable Gate Array. Basically, it is a it is an array of gates which we can program as per our requirement and field programmable. So it is basically FPGA is an integrated circuit. FPGA is an integrated circuit with having configurable blocks and their interconnection. For research point of view, to implement our research or hardware on FPGA is very much better than any other microprocessor and microcontroller. The most important beauty of this FPGA is work on parallel basis, concurrent basis, means here we flow data from input to output, and in case of microprocessor and microcontroller, when first of all we write instructions or our program in and store it in memory, then fetch these instructions one by one and execute. So it is work on sequential basis. But FPGA, the feature of FPGA is work on parallel basis, and the logic blocks are programmable, reconfigurable. We can edit our circuit, we can edit our program on runtime basis. So the term field programmable is programming in the field. In the field means at the time in the lab or where the device is installed, we can change our conditions and then reload our program and and execute our program. So FPGA is an array of logic cell, we can say array of gates, array of modules and their interconnects, which can be reprogrammed depending upon the requirement of the user. So to build a very large circuit, a very complex circuit in digital logic, so we can implement on it in any other research like power electronics, robotics, image processing, DSP algorithm. We can also implement these things on FPGA also. So this is the structure of FPGA. Here you can see these are the logic blocks. We can program this logic block as per our code, and we can interconnect via these programmable interconnects. These are basically the matrix. They lie in matrix form, and they are the programmable input-output blocks by which we can interconnect outside the world. Now, what are the family of FPGA? There are several families available in market like Xilinx, Actel, and Altera. I'm working on Xilinx, Spartan Kind given by Xilinx. Now, what is the basic difference between these Xilinx, Actel, and Altera companies product Xilinx kits? Basically, the physical means for implementing programmability, means there is a difference between implementing programmability methods, their interconnection arrangement, and the functionality of logic blocks. So they are differ by these means. Now the programmability in FPGA, as I show that Xilinx, Actel, and Altera, in these Xilinx and Altera are basically SRAM based. SRAM based means they are anti-fuse. We can burn our program, then reburn. Anti-fuse based is Actel. It is one-time programmable, given by Actel Quick Logic. So SRAM based programming is making or breaking cross-point connection, define function. We can define our function of logic block, but in anti-fuse based programming, it can only one-time programmable. Now, one question is arise why we select FPGA over general purpose hardware and DSP processor. Because first of all, one important parameter is high speed. When we work on DSP algorithms or in power converters, when we design power algorithm for power converters, inverters, so we need real-time data and complex programming. So we need a high speed. So we prefer FPGA over microprocessor and microcontroller because FPGA work on concurrent basis. Now, hardware design techniques which are possible in FPGA is both parallel and pipelining. Parallel means multiple action can be performed simultaneously, and pipelining, as we know about in microprocessor 8086 systems, pipeline is a concept in which when one program is executing, then other program is fetching or something else. Means we can perform multiple tasks in parallel form in case of FPGA. Flexible means because FPGA is a flexible device. We can add, subtract functionality as per our requirement. Next one is million instruction per second requirement for an application. When we work on real-time video image processing application, so we need fast speed and multiple instructions executed in a single time. So FPGA is very better for selecting, offer a much better cost-effective solution, because in very small amount we can choose a better opportunity when we select FPGA over DSP processors and microcontrollers available in the market. Now, what are the application of FPGA? We can design complex digital logic circuits on FPGA and implement these design digital controller for power electronic device, as I discussed that power converters, inverters. We can design algorithm on FPGA and implement on FPGA. In case of robotics, we can also use FPGA for motion control of robot, for sensing robot, and in case of robotics and image processing, we can use FPGA, DSP algorithms because in DSP algorithm they are very much large data, so we prefer FPGA for fast execution, video and image processing. So without discussing much more in detail in FPGA, I am going to introduce how we work on FPGA. For very basic, first of all, if we want to work on any tool, we need to write a program. So this is the scenario by which flowchart by which we can burn our logic on FPGA. First of all is design entry, then behavior simulation, design synthesis, design implementation, and then burn our program on Xilinx device. I will explain these block one by one. What we do in design entry. Design entry is basically the first step of implementing a design of FPGA. Here we write our code on hardware description language. FPGA work on hardware description language. We can write our program in two type of hardware description language, Verilog and VSDL. In my case, I prefer Verilog because it is very easy to understand. So we need for burning a program on FPGA, we need a software which is Xilinx ISE, and we write a program on Xilinx ISE either in Verilog language or VSDL language. Now, second point is, after writing a code, we check its behavior. So to check the behavior, we need simulation. In behavior simulation, it is a next step. In this step, we verify whether the design entered by us is functionally correct or not. If there is some error, then it shows error. We can show the RTL view in this step. Third step is design synthesis. Design synthesis is basically used when we do implementation of our code. The synthesis process is used for optimizing the design architecture selected. It gives the net list is saved on the NGC file format. After design synthesis report, basically what in this step what we are doing, synthesis report is generated, which give information about how many logic blocks which are using. There are multiple logic blocks available in FPGA. So how many blocks which are used in our designing program, and what is the device utilization of design architecture synthesis. So basically synthesis map the behavioral design to gate level design. So our behavior design, what we written in code, is converted into gate level design. So we can capture the RTL schematic of Verilog code which we are written in Xilinx ISE. Next one is to implement. Before implementation, we need to make UCF file. Now, what is this UCF file? Basically, UCF file is a user constraint file where we define that in FPGA, because it is a hardware description language. So in our program, if we take some input and output, so we have to define which pin we give input and which pin we give output. So design implementation, there are 3 steps in design implementation. First one is translate, map, and then place and route. Before translating the design, UCF file is written to assign pin configuration, as I told. Then next step is translate. First step is translate. Translate, what this step do? It merge your UCF file, as you UCF file and net list, which is generated in synthesis process, into a Xilinx design file. Now after that, the mapping process is coming. Mapping process it fit the design into available resource. Available resource means our FPGA. And the last process for design implementation is placing and routing, which place the logic blocks of design into FPGA and route them so then they can occupy minimum area and meet timing requirement. So for a very large area of FPGA, a very small amount of area is covered by this mapping process, place and route process. After that, this operation produce a NCD output file. After that, the next step is generate programming file. Actually, there are multiple steps to produce a executable file, because executable, in case of FPGA, this executable file is XSVF file. So to implement our project on FPGA, we need to create this XSVF file. So these are the steps to create XSVF file. Next step is generate programming file. There is an option for generating program file on the process tab Xilinx ISE, which convert the NCD file, this NCD output file, into a bit file. Now it produces a bit stream for Xilinx device. This bit file is used to program the FPGA, but we need XSVF file. So we will take next step, configure target device. In this step, there is an option for generating target PROM on the process tab of Xilinx ISE, which convert your bit file into XSVF file. This XSVF file is the actual file which we need to burn in your FPGA. So when your XSVF file is created, now your FPGA is ready to be used. Now, what are the steps when we writing a Verilog program on Xilinx? We need these for Xilinx environment consist following segments. First of all is header. Header means we give any name of your project. It is called module name, list of input and output which we are used in your project. Declaration means if we give name in your module name, like suppose your module name is NOR, and you give input, if you give variable ABC. Now in declaration part, you have to define what is input and what is output. Suppose A and B, we take input, so you have to define input A, input B, and if suppose our output is C, then you have to define output C. Now logic description You can describe your via equation, state, machine, or logic function here, whatever logic you want to do on your input and output. And module, you have to give AND statement, which is in Verilog program is AND module. All your design for this lab must be specified in the above Verilog input format. Now, via slide, I am going to show how to create a new project on Xilinx environment. First of all, this is when you open the Xilinx, when you install the Xilinx software and open it, this project navigator window will open. Now click to create a new project. First of all, click on File and give any name of your project. Then this window will appear. Now these are the basic setting which are given by manufacturer. Just like here I am using Spartan 6 kit and Verilog programming preferred language. You can select VSDL if you want to work on VSDL, and then click on next. And now this project summary will appear. Now click on finish. Now it make a project. Before going this, when you create a new file, this location option will show. You can give any location where you want to save your project, and you can also give the directory in which you want to save your project. Now when you click on finish, a gate window, a gate project is making. But to create a Verilog file, we need a .v file configuration here. So how to add source code and UCF file? Click on project, this one. Then go to new source and select Verilog module. There are so many options are available. Then if you want to work write program on Verilog, then click on Verilog module and then give the file name and click on next, and click on this option, add to project. So this .v file will automatically add in your created folder, project folder. Then click on next, and finish. Now here you can see that .v file is created. Similar procedure is apply for creating UCF file. UCF file where we address our input and output, means our input and output is connected to which pin of FPGA. So to create XSVF file, again we click on project, then select implement concentrate file, give the name, and then click on next, and add, finish. Now here you can see that gate, suppose I am here, I'm taking a module name gate and. So gate underscore and dot v file, also gate underscore and dot UCF file is automatically available in your project folder. Now everybody know the basic logic of AND gate. AND gate means if you both here for making an AND gate and implement it on FPGA, we need two input and one output. Here I'm taking input 1 and input 2 and output gate output. So in module name here, module under gate underscore and, we give input. This is your header file. You give name input 1, input 2 and gate output. Now you have to declare which one is input and which one is output. Basically these are the variable. So we give input 1, input 2 and output gate output. Now to develop a logic, we need a assign operator. Assign operator, we give gate output equal to input 1 and input 2. Means when your both input are 1 1, output will be 1, otherwise output will be 0. And last statement is AND module. To write UCF file, we give these instructions. To write a UCF file, we need, and we write this syntax netnet in quoted form, input 1 LOC equal to T20. Now what is this T20? T20 is a basically in FPGA from how we can give input. So in this project, I'm taking two switches via which we can give input 1 and input 2, and one LED to show the output. So T20 is the address of input 1 and N16 is the address of input 2. And for output, we take LOC equal to AA6. Now AA6 is the address of LED. So this is how we create .v file and .ucf file. This is the table of FPGA pin. Basically, I'm working on Spartan 6 given by Xilinx. So in this kit, the LEDs address is given as AA6, AB6. If I want to use LED 5, then I have to give address Y8 in UCF file, and so on. So they have 10 LEDs in this FPGA kit, and dip switches from which we can give input. So there are multiple dip switches available in FPGA. So I am taking this T20 and N16, dip switch 1 and dip switch 2. Now, after writing .v file and UCF file, what we do next? We do, first of all, before in research, there are two things we are doing. First of all, simulation, and then implementation. So how we simulate our code on Verilog on Xilinx. So for select simulation option, select your .v file, and then select behavior check syntax. If all is okay, select simulate behavior model. This window will open. Now, to check the logic, we have to verify the truth table of AND gate. So for input, to give any input, if your input is input 1, then it may be a 0 or 1. To give 0 or 1, what we do? In object window, right click on input 1, then click on force constant and give force to value equal to 1 if you want to give 1. And same procedure will apply on input 2. To run the program, click on run symbol. This is the run symbol, this one. Now click on zoom to view. This is the zoom button. You can click on it to zoom your view. Change the input and see the result. This one. When you right click on it, this window will open. Now you can give your value in binary form. So write force to value 1 or 0. Then you can see. If you give input 1 and 1, your output will be 1. So here you can see. Now if we change the input 1 and give its value 0, and input 2 is 1, then your output will be 1, so that we can verify our logic via simulation. Now, how to implement the project after simulation, after checking your code is working correctly or not? Next step is implementation. How we implement our code on FPGA. For implementation, select this. There are two options: implementation and simulation. For simulation, you have to select this option, and for implementation, you have to select this option, implementation. For implementation, your project, click on select implementation and then select your .v file, and then click on synthesize. After synthesize, this green's right will shown in front of your synthesize option. In synthesize option, when you click on this plus button, then you can show the RTL, view RTL schematic. So when you double click on it, you can show this RTL schematic of your project. When you double click on it, this AND gate, this diagram will show the diagram of your logic. Then after synthesize, implement design, double click on implement design, then generate program file. Third step is generate program file. After that, configure target device. This warning will appear. Ignore it. Click on OK. Then this window will show you. Now you click on boundary scan. When you click on it, then this window will open. Then right click on it on blank window and open .bit file, which is automatically generated when you synthesize and implement your project. Now select output, this output option, and create XSVF file. Now save and right click on device. You can give any name of your XSVF file. Then this message will show program succeeded. If there is no error in your program, then this message will appear program succeeded, and your XSVF file is automatically created on your developed project folder. By the in the similar way, you can design any of the AND or NOR XOR gate. So it is a basic example how we simulate or implement our Verilog program on Verilog program on Xilinx, write program, simulate it, and then implement on it. But if we work research point of view, first of all, we need to knowledge of Verilog program. So now introduction to HDL, I'm going to discuss some small projects and then research work. Now what is Verilog? Basically Verilog is a hardware description language. Verilog is one of the two major hardware description language. VHDL is the another one. So as I told you that Verilog is easier to learn and use than VHDL. Verilog is just like your C programming, C language. Verilog HDL allow hardware designer to describe design at a high level abstraction. Why we use Verilog HDL? Because digital systems are highly complex, and Verilog language provide the digital designer of software platform. We can simulate our before implementing. We can simulate our project or our code and then make it a IC. So we can design even our own microcontroller on FPGA. And then after checking the syntax, behavior simulation, and implementing this on your FPGA, you can give your design to manufacturer company, and they will provide you your own logic IC. Now, what is the advantage of Verilog? Unlike all the procedural language like Java, Verilog is concurrent. Concurrent means here data flow in parallel form. Now, what is the design procedure? I already discussed. To create a Verilog file, first of all, we need to create a Verilog file, compile it, implement it, then create and simulate it. Now, assign input and output. Assign input and output means we need to create a XSVF file, then download the bit stream or XSVF file on FPGA or CPLD. CPLD basically now implement your XSVF file on burn your XSVF file on FPGA or CPLD. CPLD is complex programmable logic device. Now we can test or implement it on FPGA. This is the design procedure which I discussed one by one. Now, what are the level of abstraction when we write program on Verilog? There are three level of abstraction we can write our program. First, the low level is gate level, then data flow level, and behavior level. I will discuss gate level, describe the logic gates and the connection between logic gates. I will explain it via one by one example. Then data flow level, in data flow level, flow of data between register and behavior level, designing without knowing about the hardware. You can I can explain it via example. First of all, gate level modeling. In gate level modeling, suppose I am taking a example. I am creating a module, give name gate level, and assign some variable. Write some variable a, b, y1, y2, y3, and y4. In out of these 6 variable, a and b are input, so we have to declare input a and b. Then y1, y2, y3, and y4 are the output, so we have to give output y1, y2, y3, and y4. Now in gate level modeling, we have to write these type of syntax: NAND N1. Sorry, this one is the y1. Sorry, NAND N1. This is the name, and y1 comma a comma b means we are performing NAND operation, and the output is v1 and your input is a and b. This is the writing how we write logic for NAND gate. Similarly for XOR gate, y2 is the output of XOR gate, XOR x1 is the name of XOR, and a and b. So a or the operation of XOR a or b, and the output is y2. Similarly for and OR gate. This is the gate level modeling. In data flow level modeling, here we use assign operator as we discussed in our first example. In this case, suppose we take an example, write module name gate, inv for inverter, and a comma b. So here I am declaring input a and b are the input, and out inv and are the outputs. So here we in data flow modeling we are using assign operator. Assign operator means inv is the output equal to negation of a. So negation of a will give to the inverter. Then assign and equal to, we can give any expression, or we can simply write and equal to a and b and module. So this is the procedure how we write data in how we write our code in data flow modeling. So basically gate level modeling, data flow labeling, and behavior modeling are the three methods how we by which we can write our Verilog program. So in behavior modeling, as you see in C programming, most of the cases, most of the program we use if and else statement, if and else, case structure. So in behavior modeling, we can do all these. Let's take an example, module example 1, x1, x2, x3. Here x1, x2, x3 is the input and f is the output. In behavior modeling, we have to take a same register of your name as your outputs. Such as if your output is F, you have to take register of same name F. Now always at the rate. Always at the rate means it work when there is any change in x1, x2 or x3. So when there is a change in x1 or x2 or x3, then it will begin. If x2 equal to 1, there is a logic. It is an example. If x2 equal to 1, if your input x1 equal to 1, then f equal to x1, your output equal to x1, else output f equal to x3, and is the and statement of this begin, and module is the and statement of this your this module. So I think it is very clear how we write code in gate level, then data flow level, and behavior modeling. Now, some Verilog statements. Which statements which are using in Verilog code? There are two basic type of statement. First one is concurrent statement, combinational, like this, which we used in gate level modeling, and z comma x comma y. Here z is your output, x and y is your input. Or c comma a comma b. Here c is your output, a comma b is your input. In continuous statement, you write assign operator. Assign, just write Z, your output equal to X and Y. So it is better to write this get statement. You can use continuous statement and give name assign use assign operator and write your statement. You can write your statement. Second one is procedural statement, sequential statement. So in sequential statement executed in the order written in the code. Here we use always at the rate. Always at the rate means executed continuously when the event is active. Whenever your event is active, always at the rate, this statement will begin as you show in this example. Always at the rate positive edge clock means when your clock is going to positive edge, it will become. And these statement which you write after begin, these statement will executed. Then end of this begin, if and else statement are also come into this sequential statements. As I already discussed, AND logic gate. If I am taking one more example, half adder. Half adder, in half adder we define module. Half adder, sum, carry, A and B. A and B are your input, output, sum and carry are your output. So as we know that in half adder case, there is sum is basically a XOR B and out carry is the A and B. So we can assign sum equal to A XOR B and assign carry equal to A and B and module. Similarly, we can design full adder. So in full adder, this is a truth table of full adder. And we know that when all the three inputs are 1, your sum and carry will 1. Otherwise, if two input are 1, then your sum will 0 and carry will 1. So this is a logic diagram of full adder. I will show all the what I am discussing till now. I will show you in a video. Let's see a video. Here, first of all, click on file, then create new project, give name. Suppose I give name full underscore adder. Here you can select the location where you want to save your data, save your project. Here I'm creating a new project and give name FPGA underscore STC. Now, for creating a new project, Verilog module, you have to select Verilog module, give name. Now here we write Verilog program module full adder ABC sum carry. This is the same procedure. Because we have shortage of time, so I come to the implementation step. Here you can see the simulation. For implementation, first of all, open the terminal and give the IP address of the system. First of all, click on terminal and give IP address of this system. Then click on ULK count, click on list ULK. It will show your IP address. Then select it and click on connect. Now this connection established. Now here you load your XSVF file. In this case, here you can see they are actually the Spartan kit which I'm using have 3 processor, ARM processor, FPGA processor and DSP processor. So for every project we need to select if we FPGA, if we want to work on FPGA, if we want to work on DSP, then we need to select DSP. So in that case I am always selecting FPGA. Now search this FPGA STC folder and search this one, full adder XSVF file. Click on it, then click on open. Now load it. Okay, click on OK. It will take some time, few seconds. Now file successfully loaded. Now click on run. Again select FPGA and execute. Then click on OK. For doing so, it implement your XSVF file on FPGA. Now FPGA programming success. Click on OK. Now this is the FPGA Spartan 6 kit. Here you can see these are the dip switches 1 and 2, and 1, 2 and 3 in case of full adder, and 3 LEDs. If I'm pressing 1 means 1 in 0 0 1 0, then sum will be 1. Only some LED will glow. But when we press 1 1 0, then what will happen? Sum is 0 and carry will 1. And if we press 1 1 1, means both sum and carry will 1. Similarly, you can do for programming for 2x1 multiplexer, 2x4 multiplexer, decoder. Now I'm taking a case of 4x1 multiplexer. As you know, 4x1 multiplexer depends upon 2 select line. If both S1 and S0 are 0 0, then D0 will appear on output. If 0 1 select line are 0 1, then D1 will goes to output. Then if they are 1 0, then D2, and after that D3. So at a time 4x1 means any input, a single input can deliver to output, but one at a time. It depends upon the select line. So this is a Verilog module program, V program. Here you can see module mux D in, D select, D out. Output is D out is the output. So it is a program example of sequential programming. So when we take D output, D out, so similar name we give to the register D out. Because the inputs are 4 inputs, so here I am taking input an array 0 colon 3 means 0 1 2 3, 4 bits for input, and these name are D in, and similarly 2 select lines, so we give name input 0 colon 1 because we using 2 select lines select. Now always at the rate D in or select. If there is change in D in or select, it will begin if select equal to 0, means if the select lines are 0 0, select lines means S1 and S0 are 0, then your D out equal to D in 0, because your D in is the input and it has 4 bits. So if select equal to 0, then D out equal to D in 0. Similarly, else if select equal to 1, then D out equal to D1, and so on. You can you can see the behavior simulation. If I am taking the input 1100 and select line is 00. Now, if your input is 1100 and when you select input, select line 00, now what will happen? This 0 bit appear on your output. When you select 01, then again 0 will appear on output. When you select 1110, then 1 will appear on your output. These are the 4 cases. Now I will show the video of this project. Now I am going to take only implementation part. Here you can see UCF file. I am taking 4 input switches, 2 select lines. Select lines are also for, we are taking 6 input, basically 6 dip switches, 4 for input and 2 for select lines. Then give D and net D out LOC. This is your single output, which is an LED. Same procedure will repeat. And implementation, same procedure. Here you select mux.xsvf file and load it. Now you can see. Here I am giving the 4 data input 1101. 1101 means if your select line is 0, then output will be 1. Similarly, you can verify your logic on FPGA. Now next one. You can do your programming in case statement. There is an example of BCD to 7 segment. In case of BCD to 7 segment, there are 2 type of segment connected to common cathode and common anode. In my case, when you want to blow this segment, so give 0 to it. If you want to off this segment, give 1 to it. So this is a table to BCD to 7 segment. Here's a Verilog program BCD to 7 segment. Here you can see I am taking BCD as an input, segment 7 and segment 7 select, because in my kit there are 4 segments. So to select any one of them, I need one variable, segment 7 select, and segment 7 which we want to display on your 7 segment. So these are the outputs. So we need to take output as well as registers. Now input is a 4-bit, so we take input 3:0 BCD, always at the rate BCD. Whenever there is a change in BCD, begin. Now select segment 7 underscore select equal to 4 in case of binary. When we write our data in binary form, so we have to write these 4 comma colon B 1110, because we have 4 segments and we need we want to select segment LSB segment, so we need to give 0 for it. So we write 11110. This is a case BCD. When you pass 0, then this is the code for displaying 0 on your 7 segment. 1, we need to pass F9 on your 7 segment. Similarly, 0 to 9. Then if you want to display A to F, then you can write these code. Then AND case, because we are working on case structure, then you have to AND via AND case. Then AND is the last statement of your begin. Then AND module. AND modules means this is the last statement of your project. Now you can see the video of this experiment. Here I am going to interface 7 segment via FPGA. Excuse me, ma'am. What's going on? किधर
प्रेजेंटेशन है ना जो यस
नहीं वो चल रहा है ना
वीडियो आपकी गायब हो गई, वो फोल्डर ये जो फोल्डर है ना इसे करिए।
नहीं वीडियो तो ये रही
ओपन
कर दे। ओके ओके here you can see I'm going to the implementation process because it's a lengthy process, so I am going only on show only the implementation process, how actually it works. When you nothing press 0 0 0, then it will show 1. When you press 1, it will show 1, then 2. When you give 3 via switches, then it will show 3. And because I am there are 4 segments, I am selecting this segment, left hand side segment, so that's why I'm giving segment select. So when what value you are passing from this switch in BCD form, it will show in your output 7 segment. 6, then 7, 8, 9, A, capital A, B. We write B in small form because if we write B in capital, then there is no similarity between 8 and B. C, small d, again E and F, so on. So we can interface now, up to now we interface dip switches, LEDs and 7 segment via FPGA. Now one more important thing, why in case of FPGA, for generating PWM signal via FPGA is very important. As you know, the PWM generation, here you can see, here I am taking a counter value because our FPGA is working on crystal frequency equal to 100 megahertz. So if we want to calculate the time period, it is 1 upon F. So we can calculate, means 1 single tick equal to 10 nanosecond. So if we want to give the counter value to 2500, then equal to 2500 into 10 nanosecond means 2500 equal to 2500 equal to your 25 microsecond. Now to convert in frequency, you can see that frequency equal to 40 kilohertz, means if we want to work on 40 kilohertz, we need to give counter value 2500. So means your counter is reaches 0 to 2500. So, and this is the reference value. Reference value is the value which is always it compare it with reference value. When it reach to the reference value, until it reach to the reference value, your T on equal to 1, otherwise your T on will be 1. So maximum counter value to equal your counter value equal to maximum switch. Then for 2500, for equaling this equation, you need to multiply a scaling factor. I am going to show in my program. Here I am taking, now I am going to generate a PWM signal via FPGA. So I am taking this example module PWM clock PWM switch. Here parameter SD. SD is the parameter here for scaling factor to equalize these equation. I am taking SD parameter, input clock switch. Here I am taking 8 switches, means what I am going to do, I am controlling the width of, I am going to change the width of PWM via switches. Now this is your output PWM register. I am taking a 16-bit counter and initialize it with 0 value. Because output is PWM, so we take a register of same name, register PWM. Now always at the rate positive clock. When your positive clock is begin, then your counter is incremented by 1. Now if your counter is less than equal to SD, SD is the parameter which you already define in your program, 10 multiplied by SW. SW is the value which we are going to give by FPGA switches. Now whenever this parameter, your counter is less than equal to this parameter, then your PWM equal to 1. And when this condition is false, else PWM equal to 0. And what up to, if your counter is greater than equal to 250, matlab means these equation will execute until your counter value is greater than equal less than equal to 2500, and if it is above, then your counter will be 0 and end module. This is the experimental setup to generate PWM signal on FPGA. This is the different duty cycle. I will show you with the help of some with the help of video. Again, for creating project, I am going to the implementation part. Here you can see I am giving some value to 8 switches, and here I am connecting the DSO and take the signal from FPGA. Here you can see via giving some value via switches, this waveform will appear. Now if we want, if I am change some value via switch, the width will vary. Yes, it vary. The width of PWM is vary. So we can change the value of switches. I am taking 8 switches, so you can change the value in binary. 8 times 1 means 0 to 255. We can change the value, and this you can see the width of PWM T on will increase. So what is the use? Why we using PWM signal? What is the use need of this generating PWM? Basically, in research point of view, in power electronics, if we want to control the T on T off time of a MOSFET or any power electronics device, so we use the concept of PWM. In next case, I am going to control the speed control of DC motor. Here you can see instead of switches, I am taking a potentiometer as an analog, and because potentiometer give analog value, then I am using an Arduino working as an external ADC, convert the potential analog value coming from potentiometer into digital, then giving it to this input output expansion port of FPGA. Now they give the output signal, which is PWM, to the ULN2003 IC. This is a IC used to control the speed of motor. Here you can see by rotating the value of potentiometer, the speed of the DC motor will vary. Now you can see this one. So we use the concept of PWM in many applications. Next. This is the same program which I written in PWM program. And fire alarm and protection system based on RF. We can interface RF module with the help via FPGA. I'm just showing the video. Here you can see in this project, I am using 2 kits. One for transmitter side and another for receiving side. In transmitter side, I am using IR sensor and flame sensor. If there is any obstacle occur in IR sensor, then on receiving side, LED will be shown. And if there is an flame sensor, if there is they occur any flame in transmitter side, then buzzer will blow on receiving side. You can see on this video. Here you can see when any obstacle occurs and it detected by IR receiver, IR sensor, then LED will show on receiving side. LED will glow. Then if there is flame sensor detect any flame on transmitter side, you can see we can on any pump motor on transmitter side, as well as buzzer will beep on receiving side. So we can communicate wirelessly, communicate to FPGA kits. Next project is road to control robot. Just a minute. Project. Okay. There are so many applications. Now in brief 2 or 3 minutes I will go to how we work implement any fuzzy logic based MPPT basically on FPGA. This is my project video. I will show. Just 2 minutes. Here I am taking a solar panel. I am taking two solar panel, fixed solar panel, and panel based on sun tracker. Here you can see. This is my project setup. Basically, what is my project? To design an implementation of fuzzy logic based MPPT on FPGA. So when I am taking data, current and voltage directly from solar panel and without involving the MPPT, which I implemented on FPGA, then it will give this. This is the circuit of where I'm taking voltage and current and converted into digital form and boost converter. Here you can see that voltage is 17.23 without using MPPT. But when we apply our algorithm here, then this circuit is also on and this boost converter is on, and you can see then power and the voltage is boost up to 27.90. So we can implement any logic, any algorithm on FPGA and give better results. Thank you so much.